Okay, I want to do an example for you, two examples actually. You should do these in your book, I'm sorry, in your notes with you so that you have them when you're working on your problems in a minute. So, our first example is to find the magnitude and direction of the electric force on a proton in a uniform electric field with a strength of 1250 newtons per coulomb that points due east. So they've given us the magnitude and direction of that electric field. And then the second part of the problem is if the proton starts at rest, what is its acceleration? Okay, so the first thing I want us to do is to use our five-step process. Given, find, formula, work, answer. You should be practicing this at all times. I'm going to work it through that way. I'd like you to do it in your notes with us. So, givens. Now, when we first look at this, the obvious thing is our electric field. And that is 1250 newtons per coulomb. All right? The question, though, is what else do they give us? Well, that's not necessarily very clear. However, there's some things that we know from looking at the problem. They give us a proton. Well, we know the charge on a proton, Q, is equal to 1.6 times 10 to the negative 19th coulombs. And if you forget this, go look in the front of your textbook. That's where your constants are. On a test, we're going to give that to you. We don't expect you to memorize it. Also, while we're there, we know that the mass of a proton is 1.67 times 10 to the negative 27 coulombs. I'm sorry, kilograms. Kilograms. And we're going to need that because we're going to find acceleration. As soon as I think acceleration, I think Newton's second law, F equals ma. And if we're finding a force here, then it makes sense that piece is going to be the easiest connection for us. So we're given these three things, and then we're asked to find the force and the acceleration. And so now we need our formulas. So we're going to use that electric field formula, E equals F over Q. And that should make sense. We know Q, we know E, we need F. That should be pretty obvious. And then we're going to use F equals ma for the second part of this. Okay, so we're going to show our work. So we're going to start by finding the force. So let's derive the formula that we need. So we look at this first one here, and we say F equals Q times E. And it's helpful to draw a diagram here. We have a uniform field that points east. The uniform field should be evenly spaced, even lengths, right, as best as I can. And then we have a little proton in here. That's going to help us later when we determine the direction of things. Okay, so that's our little diagram over there. All right, so let's plug and chug here. So F equals 1.6 times 10 to the negative 19 times 1250. I'll give you a chance to poke that into your calculator. Okay, so I'll give you a chance to poke that into your calculator. Those of you who are done, I'm going to move forward for 1 second and then we can go back and check our answers. So once we have that force, then we're going to find the acceleration. And the acceleration, we use this formula, is F over m. Okay, so you should have gotten from the first part 2 times 10 to the negative 16 newtons. Okay? And it makes sense that we'd have a really small number. This is a really, really small number. We just have a proton. So now we look at the direction, by the way. So our field points east, right? And so the field points in the direction that a positive test particle will accelerate. We have a proton, so our force is east. Having a little trouble with my cursor there. So our force, if they ask for magnitude and direction, is 2 times 10 to the negative 16th newtons east, or plus 2 times 10 to the negative 16th. We can also write it this way. Please don't forget your units. No naked numbers. All right. So that now we have that, we plug it in right down here. 2 times 10 to the negative 16th. And we divide that by 1.67 times 10 to the negative 27. You're going to have to bear with me there. And I'll give you a chance to calculate that. And you should get 1.1 times 10 to the 11th meters per second squared. Now that's like a really large number, and I'm totally not going to get into whether or not this is plausible. I literally pulled random numbers for this problem. So it's about the process, okay? And so this is a really great example for you. You'll be doing problems like this in your classwork, and then I'm going to do a second video for the second example.